All right, let's look at the homework 4.1, problem number 3. Right, so let's find the critical numbers of the following function. All right, so let's see, let's take the derivative. You have, let's see, g prime of y is equal to, right, so this is in a quotient form, so I'm going to just square the denominator. So y squared minus 3y plus 3, right, squared, right? Derivative of the top is 1 times the denominator, so which is y squared minus 3y plus 3 minus, right, top, which is y minus 1, and then multiply by derivative of the denominator, which is 2y and minus 3, right? So that's by quotient rule, right? So if you multiply out the numerator, you're going to get, let's see, I'm going to just get y squared minus 3y plus 3 minus, right? So we're going to have to multiply. So y times 2y is 2y squared. Y times negative 3 is negative 3y. Well, negative 1 times 2y is negative 2y. And negative 1 times negative 1 is positive 3. Right? Then the denominator stays the same. Y squared minus 3y plus 3 squared. All right, then we can cancel a bunch of things, I guess. Let's see, you have negative 3y minus negative 3y, and 3 minus 3. All right, then if you clean it up, you're going to get, let's see, we have y squared there, and a minus 2y squared. So that's going to be negative y squared. And then we have, let's see, negative 2y. So we're going to have a subtract minus 2y. Actually, it's actually double negative, so it's going to be a plus 2y. Right, so that's everyone, and the denominator is exactly the same as before. So you have a y squared minus 3y plus 3 squared. All right, then I'm going to set this guy equal to 0. Then in order to make the fraction equal to 0, we just have to make the numerator equal to 0. And I'm going to, let's see, I'm going to actually factor out the negative y. Then you get the y minus 2, and we set that equal to 0. And you can see that y value is either 0 or 2, right? So we have critical numbers, 0 and 2. And, you know, the derivative might not be defined when the denominator equal to 0, but this is essentially the same denominator, just squared. So those guys that makes the denominator equal to 0 is not in the domain of the original function g, so they cannot be critical numbers. So only critical numbers are 0 and 2. All right, so let's type it in. All right, so we have here we found 0 and 2. So let's type in 0 and 2. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.